Measures of dispersion, box and whisker plots. A box and whisker plot is a data display that organizes data into 4 groups. Each group represents 25% of the data, known as quartiles. Quartiles are formed by calculating the median, the lower quartile, the upper quartile, and the extremes. The least data value is the lower extreme. The greatest data value is the upper extreme. The lower quartile is the median of the lower half of the dataset. The upper quartile is the median of the upper half of the dataset. The interquartile range, IQR, is a positive number that equals the difference between the upper quartile and the lower quartile. For a dataset with an odd number of data points, exclude the median when determining the lower and upper quartiles. The entire box represents 50% of the data. 25% of the data lie in the box on each side of the median. And each whisker, that's a whisker, and that's a whisker, each one of those represents 25% of the data. The interquartile range, or IQR, sometimes referred to as the middle 50%, is the difference in value of the upper quartile and the lower quartile. An outlier is a data point that is significantly larger or significantly smaller than the rest of the data in the dataset. To be an outlier, the data point must be positioned at least 1.5 interquartile ranges below the lower quartile or above the upper quartile. The lower extreme and the upper extreme are determined after removing outliers. In the diagram, the extremes are within 1.5 interquartile ranges of the lower quartile and upper quartile respectively. The range is the difference between the upper extreme and the lower extreme values. So here, if the lower extreme is 239 and the upper extreme is 323, the range would be 84, which is the difference between those two numbers. Create a box and whisker plot from this stem and leaf plot. First, we'll find the median. The median can be found by crossing off points from the top down and from the bottom up in order to find the middle point. Then we draw a circle around the median. The median here is 122. There are 13 data points above and 13 data points below the median, confirming that yes, it is the median. Repeat for the points above and below the median of the full data set to find the medians of each half of the data. So we need to find the median of the lower half, including 122 here, and the upper half. So we cross off the lowest number, cross off the highest, etc., until we get to the lower quartile, which is 105, and the upper quartile, which is 133. Determine if there are outliers by finding any values that are 1.5 times the interquartile range below the lower quartile or above the upper quartile. So the IQR, the interquartile range, is 133 minus 105, which is 28. 1.5 times 28 is 42. Therefore, outliers would be below 105, so 105 minus 42 would be 63. And no, there's no numbers below 63. And outliers above the data set would be 133 plus 42, which would be 175. Since all the data values are between 63 and 175, there are no outliers. And since there are no outliers, the lower extreme is the smallest value, 88, and the upper extreme is the largest value, 148. First, we plot all measures of dispersion. So our lower extreme is 88, upper extreme is 148. The median was 122. The lower quartile, or the median of the lower half of the data, was 105, and the upper quartile is 133. Then we draw our box and our whiskers. Find the interquartile range and outliers for this dataset and create a box and whiskers plot. First, we find the median. So because there's an odd number, there is exactly one median, it is 9. Then we find the median of the lower half. Since it's even, we have to average the two middle values, giving us a 4 for the lower quartile, and we have to average 15 and 17 to get 16 as the upper quartile. Therefore, the interquartile range is 16 minus 4, which is 12. The lower quartile is 4, the upper quartile is 16. The IQR is 12. To be an outlier, the data point must be positioned at least 1.5 times the IQR away from the lower quartile or upper quartile. Therefore, the lower limit would be 2 minus 18, which is negative 16, and there's no value smaller than negative 16. The upper limit would be 16 plus 18, which is 34. There is an outlier. 43 is bigger than 34, so that's the only outlier. Now that the outlier has been identified, the lower extreme and the upper extreme can be found. They are the lowest and largest non-outlier numbers. The lower extreme is 2, the upper extreme is 17. Now we plot all measures of dispersion, and we keep the outlier in there to figure out all of these measures of dispersion. So the median is 9. The average of these is 4, so that's going to be our lower quartile. The upper quartile will be the average of those, which is 16. Our lower limit, remember this was to find our outliers. We already did that. We have one outlier here. We have a lower extreme of 2, upper extreme of 17 because we don't include the outlier. All right, so our box goes from the lower quartile to the upper quartile, from 4 to 16. Our median goes right in here at 9. Our lower extreme is 2, our upper extreme is 17. There is an outlier over here as well. Create a box and whisker plot for the data set below. Identify any outliers. Crossing out values from the bottom up and the top down, we find the central value. The median is 52. The lower quartile is found by crossing out values from the bottom up and from the median down. The median of the lower half of the data is 48. The upper quartile is found by finding the median of the upper half of the data. So we cross 52 and 79, 56, 57, and we get an upper quartile of 56. The IQR, or interquartile range, is the difference between the lower and upper quartiles. So that's 56 minus 48 gives us 8 for our IQR. Outliers are more than 1.5 times the IQR below the lower quartile or 1.5 times the IQR above the upper quartile. So therefore, 48 minus 1.5 times 8 gives us 36. Are there any numbers here less than 36? No. So there's no outliers to the left. All right, so then we have 56 plus 1.5 times 8 gives us 68. Are there any outliers above 68? Yes, 79. The only outlier is 79. Excluding 79, the largest value is 57, so that will be our upper extreme. The smallest value is 46, so that is the lower extreme. All right, so let's plot our measures of dispersion. We have our lower extreme at 46, upper extreme 57, lower quartile 48, upper quartile 56, median 52, and then we plot our little outlier over here. We draw our box and our whiskers. All right, let's find the measures of dispersion of this stem and leaf plot. Crossing out from the bottom and the top, we get to our middle value, 44. That is our median. Then we find the median of the lower half of the data by crossing out from the bottom and from the top till we get to our middle value of 38. That's our lower quartile. The median of the top half of the data is 56. All right, we have to figure out if there's any outliers. So we have our lower quartile is 38. So we take 38, we subtract 1.5 times the interquartile range. The interquartile range is 56 minus 38, which is 8. So then we get 11. Do we have any numbers that are less than 11? No. All right, 56 plus 1.5 times 8 gives us our upper limit of 83. And there are no numbers above 83. So therefore, there are no outliers here. Therefore, our lower extreme is just the lowest value, 26. Our upper extreme is the highest value, 73. We draw our box. We have our lower quartile at 38, upper quartile at 56, our medians at 44, draw our box and our whiskers. Does the data set have any outliers? If so, which numbers? All right, so first we find the value in the middle, our median. It's 74. All right, and then the median of the lower half would be 52. That's our lower quartile. The median of the upper half is 83. That is our upper quartile. Therefore, our interquartile range is 83 minus 52, which is 31. Multiply that by 1.5, we get 46.5. Take our lower quartile, subtract 46.5, and we get 5.5. There are no numbers less than 5.5, so there's no outliers on this side. The upper limit, we take our upper quartile and we add 46.5 and we get 129.5. So we do have an outlier because this is greater than 129.5. Does the data set have any outliers? If so, which numbers? The number in the middle is the median, 18. To find the lower quartile, since we have an even number of numbers here, we have to take the average. So the average of 1 and 13 is 7. All right, the average of 22 and 25 is 23.5. So that's our lower quartile and our upper quartile. The interquartile range is 23.5 minus 7, which is 16.5. Multiply that by 1.5 to get 24.75. Therefore, we subtract 24.75 from our lower quartile to get negative 21.75. Are there numbers in our data set less than that? No, so there's no outliers to the left. Then we take that 24.75, we add it to our upper quartile to get 48.25. Are there any numbers in the data set greater than 48.25? No. Therefore, there are no outliers in this data set.